Welcome back everyone, Energy Fabricator here. What you just saw was the output of my new 20 kV DC power supply. It's running off 12 volts DC, which feeds into this circuit here, which is a plasma ball power supply. It's essentially a 555 timer running a flyback. The flyback at the moment is feeding into this high voltage multiplier. It's a 5-stage multiplier that I've salvaged out of an old school TV. The output of this multiplier feeds into this multiplier, which is again another 5-stage multiplier out of another old school TV. And the output of this multiplier goes through this grey lead over to these two caps here. And I've got the negative rail coming out to the other side of these two caps. The caps are rated at 50 kV and each one is rated to 1 nanofarads. So we have 2 nanofarads across the output of this power supply. I've also got this alligator clip here connected to this chicken stick so that we can effect a discharge between the terminals. So what we'll do now is have a bit of a play around with this power supply as it is. Once we've done that, I will remove these two capacitors here and place them with a spark gap, which will create a high frequency pulse DC discharge. Once we've got that, I'll be able to connect the plasma ball via one wire to either side of the output, and that will produce a plasma inside the plasma ball. So we'll have a look at that discharge, and then once we've done that, I will hook up the longitudinal electricity device, and we will put the electrodes on either side of the plasma ball, just as we did in the last experiment, and we will create a wireless longitudinal plasma discharge inside the plasma ball. Once we've got that up and running, I will be turning on this power supply while it's in high frequency pulse DC mode, and we'll connect that up to the terminal here at the base of the plasma ball, which feeds into the center of the plasma ball there, and see if we can use this pulsed high frequency pulse DC to modulate the longitudinal wireless plasma that we'll already have running inside the plasma ball. So without further ado, let's get into it. Okay, so this is the discharge that's produced when the 20 kV DC power supply is running in a high frequency pulse DC mode. So at the moment, as I said earlier, the capacitors have been removed from across the output terminals and replaced with a spark gap. The spark gap that I'm using here is a standard automotive spark plug. The plasma ball is connected via one wire to the positive output side of the spark plug. Okay, so this time we've got the longitudinal device producing the wireless plasma, as you've already seen, and I'm about to switch on the 20 kV DC power supply, and you can see immediately the difference between when it is on and when it is off. There's two main notable differences. The first one is that when the 20 kV DC power supply is switched on, the center of the plasma ball glows a bright red, and the second thing is that the main streamer discharge seems to want to stick towards the center of the plasma ball and seems to be attracted to the high frequency pulse DC. You can see that it doesn't rise as high as it does when the pulse DC is switched off, as we can see here. Now it's switched back on, you can see that the streamer rises with an increased frequency, but it's always tending towards the center of the ball. Definitely attracted somewhat to the pulse DC. There's a couple of things that I didn't tell you about the power supply. We can adjust the amplitude and the frequency, which is what I'm doing now, and we're affecting the plasma to produce sort of an alternating pulse on either side of the main streamer, as you can see there. Played around with this for a while, produced a few different types of effects, but I think it requires further investigation with a different set of vacuum chambers. Okay, so now we can see that by using a high frequency DC at 20 kV, we can clearly modulate a wireless longitudinal plasma discharge. The next round of experiments that I want to do include being able to modify the pressure within the vacuum chamber during the operation of the DC modulation pulses and during the operation of the longitudinal device. I believe that by doing that we should be able to see a wide range of discharges at different pressures. So there's definitely more experiments planned along the lines of modulating this longitudinal plasma. So please subscribe, leave comments, and thanks for watching.